Alright, so we're going for E, which is the sine function. Welcome back. So we'll do sine E, find d dx, sine x squared plus 3, or we can assign it as y equals sine x squared plus 3. So we can let u equal x squared plus 3. We can use it in either method, and this can be rewritten as y equals sine u, and so we can have dy u, and there's our chain rule, just going backwards a little bit. This thing can be rewritten to make sense with the u, so sine u, and so there's your d dx. Chain rule. Alright, so the only thing that's the same is the middle term. Alright, so that's an equals, isn't it? Alright, so we can do the calculus now. The calculus on u equals x squared plus 3 is du dx, so that just becomes 2x. dy du is the sine is cos, and sine is cos, so they're the same. Those two outside ones are the same. So what we want to do then is put the chains together. So dy dx ddx is equal to ddx still, going through something else, which is d du u dx. Over here we can write this as dy dx, which is still going to be going through u, just as the other one is, dy du, and it just gets you used to acclimatise using these rates. There's a slight change in the way it looks, but they're essentially the same thing. So we put them together, 2x sine u, sine and u was x squared plus 3. So that's that part, and this will be the same, 2x sine x squared plus 3. So we get the same thing. So irrespective of whether you're doing it as an equation or as an expression, you're going to end up getting the same thing. So we can check sine x squared plus 3, sine x squared, so it's to the power 2 plus 3, and we can put that in there. Control V, and we can do that. So sine x squared plus 3 ddx, or differentiating y equals, is 2x cos, and so that should match what we have done. What did I do there? Oh, I wrote sine in. Now why did I do that? I have these in me, don't I? I have these little errors. Here's geez, and it's not sine, it's cos. I did it up here correctly. For some reason I just pulled it down. So it just shows you that you can make mistakes quite readily. So it's good to check things. 2x cos, so 2x cos, so y dash dy dx equals y dash, or f dash of x, however you want to express it, or mt. Okay, any of those things apply here as well. So whether it's an expression or an equation, I guess that's the interesting part. Alright, so we were looking at E, so we're now looking at F. So F is equal to cos x3 plus 9x So we're ddxing this, cos x3 plus 9x, or if you like, we're assigning it to y and dealing with it as an equation. It's up to you how you do it. But in either case, we can let u equal x3 plus 9x, and then we can rewrite this in terms of u, and we can do the dy du. So that's how we would normally do it, put them together. Over here it's a bit trickier because now u means that we can't do d dx cos u. That won't work, so we have to make it so that it makes sense. So d du cos u will equal something. So that's our term for that side. If we go through and do the actual integration, we'll get the differentiation plus 9. So that's the first part of our chain. The differential of sine is cos. So the differential of cos is minus sine. They're your chains to put together. So you put your chain together, y dash dy dx. I know I won't do all of the bits in the middle, but it'll be minus in a bracket 3x squared plus 9 sine in a bracket x cubed plus 9x. So they look like a lot, don't they? I've just put the minus out the front, algebraic term out the front for convenience sake. So here it's the same thing. This will be minus sine u. So we're putting this chain together with this, d du dx. So the d dx of cos x3 plus 9x is equal to, putting the chain together, plus 9 sine x3 plus 9x. Same thing. Alright, so I know I'm being a bit ad nauseum, but I have very strong feelings that your performance in Maths 1 will be better with expressions rather than equations, and I just, anecdotal experience has kind of borne that out. Alright, so for G, we're going to ddx tan 3x4 plus 2x, or we're going to assign y to tan 3x4 plus 2x. In either case, we're going to let u, so we'll just let that go, let u equal 3x4 plus 2x, so u dx. Then we've got y equals tan u, so we've got dy du. Okay, now if we're doing it the other way, then we'll have to change the d dx tan to d du tan. So this is forming our chain now. Tan u equals. So they're going together in pairs. That's a chain for the equations. So I'll do the equations in red. That's the chain for the equations. Okay. And for the expressions, that's the chain for the expressions. Okay, we're not doing both all the time, we're just doing selectively bits. Okay, and I'll start to alternate them, I think, after this one, because there's probably enough doubling up to show you the difference. Okay, so we can go for our calculus now. This one is 4 3s are 12, x cubed plus 2, tan is sec squared u. Sec squared u. So we put our chains together, and it means that the d dx of tan 3x 4 plus 2x is equal to, the chains are put together, that's this pair for the green one, so put it in a bracket, 12x3 plus 2 sec squared u itself was 3x4 plus 2x. So just putting them all back together, and y dash is equal to y dx is equal to the same thing. So whether you're doing it with an equation or you're doing it with an expression, you're doing the same thing. Okay, so that's G, and the final one for this question is H. So I'm just going to do d dx sine of 4x5 plus x3. So we'll let u equal 4x5 plus x3. Du dx is equal to 20x4 plus 3x squared. So this now becomes du sine u, which is equal to, differential sign is cos u. There are our chains to put together. d dx, there it is. So d dx is equal to, I'll put it in brackets, 20x4 plus 3x squared cos u 4x5 plus x3, and that's our final derivative. That's what it equals. Okay, so you can use the, I'll leave it to you to do the equation. I said I'd alternate them, so I'll do that now. So question 2, we'll start off with A. It simply says the ln of 3x, differentiate the ln of 3. Okay, fine. So what I'll do is I'll assign y to the ln of 3x just because I can. What I want to do, of course, is make u equal to 3x, and so I'll be finding du dx, and also I can rewrite this as y in terms of u. So y in terms of u, okay, and dy du. Dy du. And so what we'll have is, this is 3, this is 1 over u. Okay, and if we put the chains together, that means we put these parts together. So we're going to have 3 on top. So y dash, which is dy dx in this case, is going to be 3 over u, which is 3x. They'll cancel, and so we'll get 1 over x. Bit unexpected, but nevertheless, that's the result. Okay, so just doing these, you're just laying out your scaffolding. Please don't use shortcuts. I believe that you'll be doing yourself a great disservice if you do that. Alright, so I'll do this one. That was an equation, wasn't it? So I'll do B as an expression, and then I'll stop, and we'll come back. So I'm going to d dx, the ln of 9x plus 1. I will let u equal 9x plus 1. So du dx is equal to that. This now becomes d du, the ln of u. So now we can do the calculus. Over here it's 9, and this becomes 1 over u. So our final d dx is equal to, so I should probably write it like that, is equal to 9 over u, which is 9x plus 1. We can't do any cancelling, so don't try that. And just to firm that up before I end this video, so we're going to do the ln of 9x plus 1. Just grab that one. Control copy. Send it on its way. And send it on its way. So we get 9 over 9x plus 1. 9 over 9x plus 1, which is consistent with what we said. And you can't do any algebraic changes to that. Alright, that wraps this video. I'll start a new one. I'll be back shortly.